So good morning everyone. Today in this class we will be dealing with product exhaustion problem. So before analyzing this problem we should know what is the basis of this problem. So during the early period of the 19th century, many economists like Clark, Marshall etc. they have found a theory called marginal productivity theory. So according to this theory, it says that the factors of the production will be paid or they will be paid their rewards according to their marginal product. So what is this basically what does this marginal product means? So marginal product or marginal physical product, it is a change in the total output of one additional unit when one additional unit of input is added to the production. That is, when a new labor or when a new unit of capital comes into the production process, what is the additional output that they produce? Okay. So what are the factors of production? Factors of production includes land, labor, capital and organization, and the rewards for the land, this particular factors of production includes rent, then profit, then wages as well as the interest. Okay. So this is the marginal product. So basic explanation of marginal product, and mathematically marginal product of the nth output can be defined as the total product minus the total product of the n minus 1 output. Okay. So this was the thing, this was the basis of this particular product exhaustion problem, which came to be called as the marginal productivity theory. Okay. So during this, when this particular theory was propounded in the early period of the 19th century, many other economists like that is J.B. Clark, Marshall, Hicks, they all explained this theory, this marginal productivity theory. So when they explained this theory, the one serious question began to pop up in the minds of other economists, over which they debated for a long time. And the question was, if all the factors of the production were paid according to their marginal product, would the total product be just exhausted? So this was a serious question. Okay, that means that if we pay all the factors of production which we said before, that is land, labor, capital as well as organization, on the basis of their marginal product, would the total product get vanished away? Okay. So this was the question and this was the problem. So the problem of proving that the total product will get exhausted once if we pay all the factors of production according to their marginal productivity came to be called as adding a problem or the product exhaustion problem. Why it is called as product exhaustion problem? Because the product is getting, total product is getting exhausted or it is getting vanished away. Okay. So this problem of the total product getting vanished away came to be called as adding a problem or product exhaustion problem. Okay. So as far as our subject is concerned, we will start to analyze any problem after making some assumptions. Okay. So for this particular problem, for this particular theory also, we have got certain assumptions. Basically 2 assumptions are there. The first assumption is that there are only 2 factors of production, that is labor as well as capital. We are not considering the other 2 factors of production, that is the entrepreneur as well as the land. Okay. So these 2 factors only are taken into consideration, and the second assumption is that one among the factors will be held constant so that the variable factor can be increased to know the marginal product. Okay, that is a particular factor's marginal product can be known only if it is variable. That is, we should increase the quantity of the input, then only we can understand how much contribution this additional input is making. Okay, so that we will keep one factor as variable and the other one as fixed. Okay. So this is the illustration of the problem. You have 2 panels, panel A and panel B. Okay. So first we will be considering panel A, where we take capital as constant and labor is variable. Okay. And quantity of labor is taken along the x-axis and the marginal product is taken along the y-axis. Okay. So this figure, both of these figure, it elucidates the problem or problem of product exhaustion, and not only that, this also shows the marginal productivity theory. And as we all know, marginal product, it will start to decline once we add more and more units of input. Okay, that is if we add more and more unit of input, the additional contribution that this input makes to the total output gets diminishes. Okay, that is why this MPL curve or the marginal product of labor curve is declining. Okay, so you can see the quantity of labor along the x-axis, and the quantity of labor of this economy is OL. Okay, imagine or assume an economy where there is only OL amount of labor, okay, and you have the marginal product of labor, and the wages according to the marginal productivity theory will be determined at the point of equality between marginal product of labor as well as the quantity of labor. So when this get equated, you can see that OB is the wage level or the wage per unit of labor. Okay, and when this wage per unit of labor gets multiplied with the quantity of labor, you will get the total wage share in the economy. Okay, so if you have the total product, that is total product of the economy, then OBAL unit of the or OBAL share of the total product will be gone for wages, or it will be set aside for paying the wage bill. Okay, and the residual part will be for the fixed factor, that is capital, and the fixed factors reward is interest, so the residual part will go to the interest, or it will go to the capital. Okay, so in the panel B, you have another situation where we consider labor as the constant factor and the capital will be the varying factor. Okay, so you can see the quantity of capital is taken along the x-axis and the marginal product along the y-axis, and marginal product of capital also diminishes because whenever any factor of production, let it be land, labor, capital or organization, if we employ more and more units, then their marginal productivity will fall. Okay, so you can see if we consider an economy where there is only OK level of quantity of capital, then getting it equated with the marginal productivity of capital, you can see that the interest rate will be OD. Okay, and the multiplying this OD level with the quantity of the capital, you can get the total share of the interest. Okay, so out of the total product in that economy, this ODCK level of or the share of the total product will go for payment to the capital as interest, and the residual part will go to the labor. Okay. So in order to prove that the total product will get vanished, okay, after payment to the factors of production according to their marginal products, what we should know? We should know that the area of this particular interest rate, that is MBA, should be equated with ODCK, and the area of the wages, that is DMC, should equate with the OBAL. Okay, and mathematically it was proved that both of these areas were equal or same and nothing is left over. So the total product gets vanished. Now, what is the best explanation for this product? For this problem, what is the major or why this particular problem is happening? Okay, so it was Philip Wicksteed who took a special interest in this problem and tried to provide a solution. Okay, so it was him who tried to analyze this problem and provide a solution. So to provide a convincing solution, he is using a particular mathematical proposition which came to be called as Euler's theorem. Okay, so Euler's theorem is a mathematical proposition. This was used in economics in order to provide a better solution for this problem. So here we are again considering an economy where there are three factors of production. Okay, labor is denoted as A, capital denoted as B, and entrepreneur denoted as C. So assume an economy where there are three factors of production. Then we can state the adding up problem mathematically as follows, that is total product is equal to marginal product of A, that is marginal product of labor, into the quantity of labor, plus marginal product of B into the quantity of B, plus marginal product of C into the quantity of C. Okay, so this is the mathematical explanation of the adding up problem. So how we can derive the marginal productivity or marginal products? This mathematically we can get the marginal products using partial derivatives. Okay, and you can see marginal productivity of A or the labor can be found as delta P divided by delta A, and similarly marginal product of B is equal to delta P divided by delta B, and MPC is equal to delta P divided by delta C. That is, delta P is the change in the total output due to a change in the or due to an addition of the labor. Okay, this is change in the total product due to an addition of capital, and this is change in the total product due to a change in the amount of the entrepreneur or the number of the entrepreneurs. Therefore, we can the initial I showed you the mathematical expression of the adding up problem, and this can be substituted as follows: P is equal to A into delta P by delta A plus B into delta P by delta B plus C into delta P by delta C. We are just substituting this partial derivatives in the former problem. Okay. So, this is called as Euler's theorem. So, the important solution or the reason that Wicksteed put forward why this particular total product is getting exhausted is that if the production function is linear and homogeneous of degree 1, then the total product will get exhausted if they are paid according to the marginal product. Okay. So, this was the solution, or this was the major reason why the P or the total product is getting exhausted. That is, in an economy the production function is considered to be linear, and if it is of homogeneous of degree 1, then certainly the total product will get exhausted. So, this is a numerical example where we will see how this particular problem is being solved. Okay. So, you have P is equal to root of A into B. This is our production function of our economy, hypothetical economy. So, P is equal to root of A into B, where this root of A into B you can write it as A raised to 1 by 2 and into B raised to 1 by 2. Okay. So, this is our particular production function. So, we will be finding the partial derivatives, that is delta P by delta A is equal to half into A raised to minus 1 by 2 into B raised to 1 by 2. Okay, we will be simply differentiating, and you will get it as 1 by 2 root A into root B, which is equal to root B divided by 2 into root A. Okay. Similarly, in order to find the partial derivative with respect to capital or B, root of P divided by that is delta P by delta B is equal to 1 by 2 B raised to minus 1 by 2 A raised to 1 by 2, that is equal to 1 divided by 2 into root B into root A, which is equal to root A by 2 root B. Okay. So, solving this problem using Euler's theorem, you will get it to be P is equal to root B into root A. So, that is the solution to this problem. So, if we put some values, okay, that is if factors of amount of factors of production, that is A and B, are used as 4 and 16 respectively. Okay, that is if amount of the factors, let the labor be 4 and if the capital employed is 16 units, then using that production function you can solve to get the total product, that is P is equal to root of A into B, that is root of 4 into 16, you will get it to be root of 64, which is equal to 8. Okay, so the total product in the economy is 8. Okay, and if you solve using Euler's theorem also, that is P is equal to root B into root A, you will get it to be P is equal to root B into root A, which is root 16 into root 4, which is equal to 4 into 2, which is again 8. So, we can see that even if we solve it without using Euler's theorem, and even if we solve it using Euler's theorem, your total product gets to be the same, and which implies that once we pay the factors of production according to the marginal productivity, the total product gets exhausted.